Shall we give the people a couple of more minutes?
That's what we said a couple of minutes ago. Let's just start with the intro and then we'll give them time to join.
All right, perfect. Yeah, thank you very much. Hello, everybody, and thanks for joining the webinar today with us. My name is Tim Schneider. I'm the head of customer value here at Buynomics. Previously worked with BCG as well for mainly CPG clients here, so we're familiar with the matter. And I will be basically moderating the meeting today and also trying to answer the questions that might come in during the meeting. And I've here with me basically the founder and main developer of the Buynomics method, Ingo Reinhardt, who has also quite extensive experience in the pricing world, in the pricing field, and will be leading you through the webinar mainly today. And before we kick off the webinar, I would like to give you, or by kicking off, I would like to give you a quick intro of Buynomics. So basically, Buynomics is a revenue management and pricing solution, which is developed to provide you with basically 4 main pillars. So first, a holistic approach in terms of price and portfolio optimization, which you can do in our tool. Then high predictive accuracy, here really with very consistent forecasts. A very high speed to insights, so where you get like insights not in days, weeks, or months, even like from eventually other tools, but rather in minutes or seconds. And all of that in turn should give you better profitability and just a wider range of information to take into account when going for pricing or revenue decisions. Any kind of questions with regards to Buynomics or the work that we do, or how we work together with our clients, happy to take them on also after the webinar via email. So really happy to connect here with everybody. And without further ado, I would now hand over to you, Ingo, for the webinar.
Thanks, Tim, for the intro, and welcome also from my side to everyone. Thank you for taking the time and joining our webinar on this, I think, important topic, not only in our field, but I think in general in machine learning AI, there's lots of stuff going on at the moment. And what we'll try to do is put this into the context and, of course, discuss the specific challenges we have in our field in pricing, revenue management, and also want to just highlight the way we think about it and what we think the solution is moving forward. So let's get started. So I think it makes sense just to get into the topic and that we have a common understanding for the next about 25 minutes. Just to clarify a few concepts that are frequently used, and we just want to make sure that we have the same understanding when we talk about things like artificial intelligence, machine learning, deep learning, and very roughly, I think artificial intelligence is the broadest term, and that addresses questions like whenever you have computers mimicking human behaviors, and I think things that are very prominent at the moment, like ChatGPT or Bard, I think the alternative from Google, are essentially doing just that they are mimicking human behavior in a very impressive way. If you've used it or if you've seen it, we'll have a slide on this here as well, and what role this might play in pricing. But they try to mimic things that humans do, either, for example, in speech, in wording, but also in music, in pictures, generating pictures and so on. So generally AI means, or the way the term is used, encapsulates everything where computers try to mimic human behavior. Machine learning is essentially a subset of that. It's essentially a more statistical method that enables machines to learn from data. So for example, you try to fit a model to real data, and it is a set of techniques to make the model, the parameters of the model, produce an outcome that's closer to the real outcome. And it's typically part also for what we are doing in and we'll come to that in a minute, within the field of pricing revenue management, is the more relevant part. So it's essentially a set of techniques that help us understand reality better by giving the algorithms the ability to learn and get closer in their model, in their prediction to what really happens. And within that, terms like deep learning mean a specific set of techniques that use neural networks as a specific technique. And I think it's important to get started to talk about these things, to have these basic terms clarified. And I think what's the most relevant for our term and the way, if we're a bit more technical in pricing, is probably machine learning. So the type of techniques we're using to make better prediction, for example, how customers react to price changes, how customers react to changes in a portfolio, and so on. So typically when we talk about AI, machine learning, deep learning, we probably most of the time mean machine learning. And I think to many people, very pragmatically, machine learning or AI is everything when certain libraries, sklearn, PyTorch, or other things are being used, then that's machine learning. And everything else like regression and clustering and so on, that's probably often termed what people consider more to be statistics or classical statistics. There's one other separation that I think is really useful in the separation between classical statistics, more like regression methods, for example, and machine learning. And it comes from the fact that the way many of the tools, regression, for example, or lots of things that have to do with the normal distribution that's easily describable by their mean and standard variation, for example, come from an era where computation was difficult. So it comes from an era where you had to do most of the statistical work by hand, and you had techniques that fit to that reality where it's difficult to do large computations. So you would look at a sample of the population, you would look at the average, and that works very well in lots of domains. So for example, if you want to know what's the average size in your population, you just have to take a random sample, maybe even of 100 people, look at their average, and you can be fairly certain that the average of that 100 people is not so different from the average of the whole population. So this is essentially the idea, is that you come from a world where these techniques were developed, and many of the tools that we also have in pricing, price elasticity, for example, come from that world that where computation is expensive, and you have to have essentially simple tools that allow you to do many of the work you do by hand or with very simple statistical tools. So essentially the idea is that you sort of have to think before you act. So you build hypothesis of what could happen. My hypothesis is, if I increase price by 10%, I will lose 10% in sales. That means a price elasticity of -1, and I test if this hypothesis is correct. This is essentially the traditional statistical approach. And with machine learning, with the access to very large and diverse data sets and fast computers, you don't really have to do that, right? You can build very complicated model, have machine learning tools that help you analyze the model, also analyze very unstructured data. So you start essentially with the data, train a model, and then evaluate how good that model is in making predictions looking forward. So the motto wouldn't be sort of think before you act, but just do it, right? So you just build a model and then test how good that model is. And it's often, many of these models are also difficult to interpret because it's really difficult to understand what's going underneath. So I would say these are two distinct differences between more classical statistics that we all learned in university, at least if you're older like myself, and the more modern machine learning approach, which starts with the data and comes out with the model, whereas more the traditional approaches start with a model, with an understanding the dependence between price and sales is linear, so you use a linear regression, and then derives hypothesis and validates or falsifies these. So I think this is important. And I think before we move forward, I think, Jonathan, we have prepared a quick survey question, and I would like you to answer this if I manage to get it started, just because we just want to understand what you're thinking of machine learning AI at the moment. So in particular, what we would like to understand is, and if you can answer this, so are you using AI or machine learning for your pricing or revenue management at the moment? And we'll just give you another 10 seconds to answer. Probably, Jonathan, we might use the results in a LinkedIn post, right? It's all anonymized, but I think that's something interesting. All right. So I think if you want to participate and have not yet, then please make it now. Do so now, and I'll stop it in just a second. All right. Tim, can you see the results or? So if you can't see the, I'll just read it. So the first one, we already use AI machine learning. We have 15% of the participants. We are planning to, I think, kind of expected that it's 56. So the majority of people are planning to use it, and 29%, so a little less than a third, are not planning to work with AI. So we have 1 in 6 already use it, 3 in 6 are planning to, and 2 in 6, if I did this correct, are not planning to work with AI in pricing. And I think that's a result that makes sense. Happy to discuss at the end of this webinar, but I think this is in line with what we also see in other places where we ask similar questions. All right. I'll close this. Okay, so because it's an important topic at the moment and the ChatGPTs are everywhere, we tested it on a very simple pricing question. So essentially the question is, I sell my product for 100 euros, my margin is 50%, and the price elasticity of my product is -3. I want to maximize my profit. Should I increase the price of my product? So I would say a very simple and straightforward question on pricing. And the right answer is, I think, also very clear. So in the optimum margin times price elasticity should be -3. So the profit optimal price margin is 33%. So you should not increase price to increase profit. And what the ChatGPT answered, I'm not going to read it, I mean, you can ask it yourself, or we'll also share the slides afterwards, is not a very useful answer. I'll just read 2 or 3 sentences. So here in the middle, if you increase the price, each unit sold will generate more revenue, but you may sell fewer units. On the other hand, if you keep the price the same, you may sell more units, but the revenue per unit will be lower. To determine the optimum price that would maximize your profit, you would need to consider the profit you would make from each scenario and choose the one that generates the highest profit. So it's everything that it says is correct, but it doesn't really answer the question. It behaves a bit like a student who has prepared for the wrong exam here. So I think in the current state, and it's probably because it's not trained for answering pricing or revenue management questions, this answer is not at all helpful. It's not wrong, but it's not helpful. And I think this is an important point. And we've tried this on many different questions, and we see that the usefulness at the current state is very limited for answering core pricing questions. But what it can be used for, and we've also tested this, is, for example, ideation. So when you ask, how can I increase my sales? It will recommend promotions, doing marketing, all of these things. So I think there's a place in ideation. There's also something we've tested when you have unclean data. It can actually help cleaning the data and preparing it. So there are lots of roles in the periphery of pricing, but from our experience, we haven't seen any that it's really good at answering the core of pricing questions. So what's, for example, the profit optimal price, or how should I change my portfolio to increase or improve my profitability? So, and that's I think something that's good to know and helpful to know, but there's certainly a place for these type of technologies in our field, but from what we see at the moment, not at the very core of it. All right, so when we further talk about pricing and revenue management, what are the typical applications in pricing? And I think when we just very broadly think about the topic, there are two important questions to consider within our field where machine learning might be of use. The one is demand estimation. So the question of how does demand change if I change a price, if I change my portfolio or anything like that. So how do customers react to a change in offer? So this is demand estimation. And the second one is then the optimization, knowing how demand will react to a change. What should I then do with this information? So how should I maybe increase or decrease my prices to optimize my profit, if that's what I want to do? And in our experience, the first one, demand estimation, is a very difficult problem, and the offer optimization a much easier problem. That's the specific part about pricing. Why is that the case? The first one, to understand how demand reacts to, there's a whole lot of things you need to know. You need to know things like seasonalities, trends you have in your market. You need to know how customers switch between products if you make a change. You have to know how customers react to promotions, for example, how they react to price changes and so on. So there's a whole lot of stuff that you need to know to get demand estimation right. Offer optimization is, on the other hand, much simpler. For example, in the single product case that we also asked ChatGPT about, the answer is very straightforward. If you know how demand reacts, you of course know the price elasticity. You know in the optimum you have margin times elasticity, and that gives you the profit optimal price. For example, if your costs are 100 euros, if the price elasticity is -2, then the profit optimal price is 200, because you need to have a margin of 50%. So in the single product case, it's very simple. In the multi-product case, it's a bit more difficult, but you can always, if you, for example, if you're optimizing a portfolio, very quickly iterate through the number of potential price points and with simple algorithms find the profit optimum for a portfolio. So the second problem is much easier than the previous one. And this is something that's specific to pricing and revenue management. For example, in other fields, chess, understanding how the rules of the game works, very simple. Everyone knows it who plays the game, but optimizing the moves given these rules, very difficult, right? So this is something that's specific to the field, that the first challenge is much harder than the second one. And within this first challenge, there are typically two techniques that play a role. The first one is clustering. So if you have a large portfolio with different products or different product categories, typically what many do is they cluster their products in a way to say, okay, these are the more price sensitive products, these are the less price sensitive products. And then having identified these clusters, they identify or measure the price elasticity within each of these clusters. Say, for example, you have this cluster down here, and within this cluster, if you look at different price and sales combinations per week, for example, you use something like a regression to determine the price elasticity. So this is typically what's being done, and I'm happy if you have other experiences to discuss these. This is typically what's been done within the pricing revenue management field, where statistically and also where machine learning techniques might play a role. And of course, they can be used here for the clustering. There's a set of algorithms or tools that can be used here. And of course, there's also a set of tools that can be used for regression. Particularly for regression, it's not so clear how this is better than like the more traditional methods. So because a regression line that minimizes the mean square difference, for example, is in a sense already the best thing, and that can be done with traditional tools. These are the fields, and I think from our point of view, one of and these are applied typically in areas where they, of course, make sense. So, for example, you are working in topics where you have a large number of SKUs, for example, because you're a retailer or you sell spare parts for your products, where you have a couple of 10,000 products you offer, or you have something like customer specific pricing because you're selling insurances where the price depends and the specific offer depends on the specific customer. So you need to have lots of computations, or you're working with dynamic pricing in aviation, for example, where you have always a specific price for a specific situation, or you're working in revenue management. So always topics where you have many price decisions or product offer decisions where these techniques are applied. And this is typically the case in, as I also already said, in cases where you have a more complicated offer. If you just sell apples $1 each, then you don't need most of these techniques, but you need them in where they are applied in areas where there's lots of products, lots of complexity. From our point of view, one of the core problems of that, and that brings us a little bit back to where we started with the difference between classical statistics and machine learning, is that the tools we have in pricing, clustering, like or customer segmentation, but most specifically the price elasticity, is not a very useful concept for these type of techniques, because when we do something like a regression through different price sales combinations and you get a demand function, and most often these are just linear demand functions, then a particular property of that is that the price elasticity is different in each point here. So let's say you have a price elasticity of -2, as we had in many of the examples I used a few minutes ago. That is only true in this one spot. So, and if, for example, you already increased the price by only 10%, your elasticity goes from -2 to -2.7, because it's the same demand function, you're just on a different spot here. And across the whole spectrum, the price elasticity goes always in a linear demand function from essentially from 0 to -infinity. So it can take every value, and determining the specific price elasticity is only of limited use, because if you increase the price or a competitor increases the price, that changes your demand function, then you will end up in a very different place. Coming back to the classical versus statistics versus machine learning, the elasticity is a concept that comes from more the classical statistics, from a simplified world where you have to do computations by hand, but it's not well suited for the techniques we now can employ with large data sets, fast computing. This is simply not the proper concept that works best in this world, because it comes from the world where you have to do things by hand. And say price elasticity of -2 is very useful for back of the envelope computation. I increase prices by 10%, lose about 20% in sales, and that might be profitable or not profitable, but it's not made for precision decisions in our point of view. All right, so what's the alternative? And we'll just give a brief outlook in the last 5 minutes on this, how we think about the challenge. And I think this picture highlights this very well. What we want to understand, and that's where also where we are employing machine learning techniques, is we want to understand what are the preferences, customer preferences, that determine the observed outcomes. So, for example, if we are thinking of a consumer goods manufacturer selling some products, soft drinks, for example, different types of soft drinks, different sizes, different bottle types, and so on. And we observe sales, weekly sales, different sales at different prices with different promotions, all of this going on. The question is, what are that we need to answer what are the customer preferences between different brands, between different sizes and everything that produce the observed outcome. And once we have determined what customer preferences we have in the market, it's then easy to make predictions how customers would react also if we change something, if we change the price, if we change our product portfolio or anything else. So this is the core idea how we think about using machine learning and other more advanced techniques more properly within our field, is that we try to use the data, different kinds of data sources, to understand what the dynamics are that produce the observed outcomes. And what we have come up with essentially is what we call the virtual customer or virtual shopper technology. And the idea is to create large numbers of these virtual shoppers that can behave just like real people. So they have behaviors, some are susceptible to price thresholds, others are not. And we determine their preferences from, as I said, from the observed outcomes. And then we create these shoppers 1, 2, 3, each with different preferences that we have determined from observed data. I'm afraid I won't have time to explain this now in detail, but I think we have other sessions where other webinars where we do this in more detail. And the idea is essentially, once we have done this, we have read out the customer preferences from observed outcomes. We have created these virtual shoppers and they make purchasing decisions. And then when we change something, for example, the price of a product, we see how sales change. And for example, in this red product, if we increase the price, we will lose some sales and some of them will go to other products. So they turn blue or green, or they will not buy anything at all. So then they turn gray in this case. And this also allows us to understand, because of each virtual shopper's individual preferences, how customers switch between products, which is important to distinguish, for example, between cases where you only increase the price of a single product versus you increase the price of multiple products. And this allows us to understand the full dynamics in the market. And of course, when you have the units, you also have revenue, profit, promotion, ROI, whatever is important to you and understanding the market. So once we've done this and have understood the customer behavior, understood their preferences, their behaviors, how they react to price thresholds, for example, we have full transparency in the market and then can use it to predict what happens in very different situations. And here, just as a very simplified example that's based on real data, we offer these different walnuts, peanuts, hazelnuts, and so on in a market in 2 different weeks with different products in promotion. So the real customers see different offers, and the virtual customers, virtual shoppers here, replicate essentially the observed behavior. And a model like this is then trained on historical weeks. For example, you look at 3 years, about 150 weeks, use that to train the preferences, and then you can use that to predict how customers react to changes in the future. Changes in the future can be different promotions, for example, a change in the size from 700 to 800 grams maybe, or you might remove the 500 and then you see that some of the customers who have previously been here go to the 700, some go to the 250. So you can use it to make changes, and this allows you to be much more precise and take a look at a broader range of different options and how you can change your portfolio. And I think we're at the end of the time. So, and of course, some final advertisement. We of course put this in a proper solution, so you have the full transparency and a tool where you can essentially use it to make decisions on price changes, on promotion changes, portfolio changes, or changes in trade terms, see how they affect you, how they affect the retailer, and all of these things you can look at in the solution. And I think the core principle, and if you don't have to take my word for it, but can take the word of someone more respectable, is we're not trying to understand the behavior of single persons, of a single person, because that's really difficult to do. I don't know what I'll buy tomorrow. You probably don't know what you will buy tomorrow fully. So while the individual man is an insoluble puzzle, in the aggregate, he becomes a mathematical certainty. And I think we can trust Sherlock Holmes here. And this is essentially what we're also taking advantage of and what we think is the proper way forward in using machine learning techniques in pricing and revenue management.
All right. Perfect. Yeah, thank you. Thank you very much, Ingo. I think in terms of questions, we got a couple of questions that maybe directly dive in as long as we still have time. So first,
Tim, maybe we will answer one or two and then the rest per email. I think people are already at the end of the half hour.
Yeah, 100%. So first question, how do you profile virtual shoppers?
Yeah, so very much in a nutshell, so they're essentially based on existing knowledge on how people in general behave. So we have a base, like a prior understanding of price thresholds, how people value ordinal properties. So for example, different pack sizes, or in telco, different data volumes. So there are very many commonalities on how people value these more structured value drivers, and or how different things correlate with each other. So there's a lot of prior knowledge we put in, and then essentially we use all the available data, for example, sales data, transaction data, and we can also integrate insights from surveys or even expert judgment on topics that aren't available in data yet.
Okay, perfect. Do we have time for another question?
Let's do one more and then.
Okay, what is the percentage of accuracy for the prediction of this model?
Accuracy it depends a bit on the context, but it's substantially higher than typically than alternative methods, as we've said, like the regression-based model we had before, and particular it's better in questions that are difficult to answer with alternative methods. So for example, how people switch between products, and that allows us, for example, to get the difference right between increasing the price of a single product versus a whole portfolio, or differences between when competitors follow or they don't follow. So these things can be understood and modeled much better than with these traditional methods.
Okay, perfect. Thank you very much, Ingo. Yeah, and thanks also everyone else for the questions and for participating. So I think we have also a couple of other webinars coming up, so stay tuned. I think in 2 weeks again, why price elasticities are an unnecessary evil, very, very interesting topic here. And then going forward with AI machine learning with regards to conjoints and pricing and RGM strategies overall. I think all of them very interesting and always very insightful with Ingo. All right, then thank you very much, everybody, and have a great day and a great weekend.
Thank you, everyone. Thanks.
Bye bye.